So one of you asked for a video on binomial heaps, so here I am with one video. So a binomial heap is a collection of binomial trees, okay? So first we need to understand what a binomial tree is, and then we'll move on to the definition of binomial heap and what are binomial heaps, right? So first we need to learn about binomial trees, okay? Why? Because a binomial heap is a collection of binomial trees. So let us look at what a binomial tree is. A binomial tree, it is an ordered tree that is defined recursively. Okay, so what is an ordered tree? Let me write it. A binomial tree, BK, is an ordered tree defined recursively. Okay. So what is an ordered tree? An ordered tree is the one in which the children of each node are ordered, right? For example, if a node has 3 children, then there is first child, second child and third child. In case you change the ordering, then the tree will change, right? If I say this is an ordered tree, right? Let us say 7, 10, 13, 14. Okay, so this is an ordered tree, right? If I say this is an ordered tree, then it means 10 is its first child, 13 is its second child and 14 is the third child of this node called 7. In case I change the ordering of this node, or in case I change the ordering of the children, that is if I write 14 here, 10 here and 13 here. So the ordering isn't same. So this this is the difference between the two trees. That is, these two trees are different. These have now become different because these are supposed to be ordered trees. So the ordering among the children is important, right? So in case of the binomial tree, it is an ordered tree, which means there is a specific order. We cannot just change the order. In case we change the order, then the tree will change. These two trees cannot be called the same tree in case of ordered trees, right? These are two different trees. Otherwise, these are same, right? Because we are just interchanging the children. But if you are considering it to be an ordered tree, then these two trees are different because the ordering has changed, right? So binomial tree BK is an ordered tree which is defined recursively. Okay, so what is recursion? Recursion is when one function calls itself over and again. That we call recursion, right? So when we are saying that it is defined recursively, it means that there is some basic building block on which we are building it over and again, right? Which we are calling over and again to build bigger blocks, right? So the binomial tree is represented by BK, right? So let us put k is equal to 0. So what is the base condition? Have you learned about recursive equations, right? There is some base condition and there is some recurring equation, right? Let us say Tn is equal to T of n minus 1 plus T of n minus 2. Okay, when n is greater than 2, and for n is equal to 1, there will be some other condition, that is Tn is equal to 1 or 0, right? Similarly, when k is equal to 0, when the binomial tree B naught consists of a single node, right? Let me draw it. So the binomial tree B naught consists of a single node. This is the node. This is the tree B naught, right? This is the binomial tree B naught. And the binomial tree BK for any k greater than 0 consists of two binomial trees BK minus 1 that are linked together, right? What does it mean? What did I say? That BK, any binomial tree BK where k is greater than 0 consists of two binomial trees BK minus 1 that are linked together. How they are linked? The root of one is made the leftmost child of the root of another. How? Let us see. This is B naught. Now, how to form B1? How we are saying we are forming B1 by taking B2, B naught and linking them together, right? So how do we link them together? Like this. The root of one is made the leftmost child of the root of another, right? Let us say these are two B naught. B naught and B naught. So we have to link them together to form B1, right? So how we are going to link? We are going to make the root of one as the leftmost child of the root of another, right? So we are making this node as the leftmost child of the root of this, right? So how will it become? It will become like this. So this is the binomial tree B1, right? So now how to form B2? We have to link two binomial trees B1 to form B2. And how we are linking them? The root of one is made the leftmost child of the root of another, right? So there are, let us say we have 2B1. So how are we going to link it? We have to make this as the leftmost child of root of this, right? So when we'll do it like this, it will become something like this. Okay, so this is the one, right? And we have to do this here. Okay, so this and this, right? Clear? Right, so binomial tree BK is an ordered tree that is defined recursively, and we are given with B0, and using B0 we are constructing BK, right? How? We are linking two trees BK minus 1 and to form B1 and to form BK, and how we are doing it? The root of one is made the leftmost child of root of another, right? So when we link two B1 to form B2, what we have done, this is one B1 and this is B1. So these two trees are linked like this to form B2. Now how we are going to form B3? Okay, so form this tree first. This is like this, right? Okay. And now we have to link this particular tree here, right? So there is one more. Okay, so there is lack of space. Okay. Yes, right? So this is the tree B3, right? So similarly we can form B4 as well. Let me erase this. This is the tree B3, right? Okay, so B3 we have to link to B3 to form B4. Okay, so let us draw first B3. Okay, and then there is one more child, and then there is one more child. Okay, and then we have to make one more tree of this form. Okay, so this, and then 3 children it has, and then it has 2 children. This is the tree B4. Okay, so we have formed B2, B3, B4 by linking 2 BK minus 1 and joining them together, right? So we have this way, if any binomial tree BK can be constructed, right? Let me draw B0 as well, right? And B1 as well. Okay, so there are some certain properties that that are applicable for the binomial tree. So what are these properties? For the binomial tree BK, okay, so there is only one binomial tree BK, right? There cannot be more than one, because there is a specific order in which they are connected, right? Or even if when you merge any two binomial trees B0 like that, like the condition specified, like the root of one is made the leftmost child of root of another, you will only get this kind of binomial tree. You will not get any kind of binomial tree. So there is just one binomial tree BK, right? There cannot be many binomial trees BK. Okay, so how there is only one binomial tree B4, right? Because two B3s are linked. Whenever you link two B3s, the result will be this particular tree, right? So now let us see what are the properties of binomial tree. There are 2 power k nodes. Okay, so there are exactly 2 power k nodes in a binomial tree. In case you want to count, you can count it. Here it is 1, here there are 2 nodes, 2 power 1. Okay, so what is k? Bk. In the binomial tree Bk there are 2 power k nodes. So this is B1, the 2 power 1 nodes it should have. B2, how many nodes should be having in we be having in B2? 2 power 2, that is 4 nodes. 1 2 3 4, right? In B3, 2 power 3, 8. 1 2 3 4 5 6 7 8. In B4, 2 power 4, 16, right? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Right, so how do we prove it for 2 power k nodes? Okay, so we'll prove it by induction, right? So how induction works? The basis is 0. For k is equal to 0, we take the basis. Like in induction, we can take it for k is equal to 1, and then we assume it to be true for k is equal to n. sorry, n is equal to k, and then we prove it for n is equal to k plus 1. But here what we will be doing is we will be taking the basis for k is equal to 0, right? The base condition is this. It has 2 power 0 nodes. Yes, so this is the basis, b0 is the basis, and then we are assuming this to be true for n is equal to k minus 1, and then we will be deriving it for n is equal to k, right? In the normal induction we assume it to be true for n is equal to k. Here we are assuming it to be true for n is equal to k minus 1, and then deriving it for n is equal to k, right? So there are 2 power k nodes. How is this possible is, here it is true, for k is equal to 0 it is true, right? Let us say for k, let us assume that for n is equal to k minus 1 it is true, right? For k minus 1 it is true. That is in that is in the binomial tree bk minus 1, there are 2 power k minus 1 nodes. Let us assume this, that for binomial tree bk minus 1 all these properties are true, right? And then we will derive it for k, right? So for bk minus 1 if it is true, then what it means is that in that particular tree we have 2 power k minus 1 nodes, right? So how is bk constructed from bk minus 1? How is bk constructed from bk minus 1? We are linking two binomial trees of bk minus 1 to form bk, right? What we are doing is we are linking two bk minus 1 nodes to form bk, right? So the number of nodes in bk will be twice the number of nodes in bk minus 1. Yes or no? Because we are linking two binomial trees bk minus 1 to form bk, right? So number of nodes in bk will be twice the number of nodes in bk minus 1. So number of nodes in bk will be twice the number of nodes in bk minus 1. Let us say k. So how many nodes are there? Don't let us assume k. Number of nodes in bk is equal to twice the number of nodes in bk minus 1, right? So how many number of nodes are there in bk minus 1? 2 power k minus 1, so it becomes 2 into 2 power k minus 1. So what is this? 2 power k, right? Isn't it? 2 power k. So we have proved that a binomial tree bk has 2 power k nodes, right? So we will prove all the properties by induction, right? The second property says that the height of the tree is k. How is that possible? Is height of the tree is k. Okay, so what can be the height of bk? Okay, the height of bk will be equal to the maximum height in bk minus 1 plus 1. Why? Because what we are doing is we are combining two trees, right? Let us say we are combining 2b1. Okay, so whatever is the height, maximum height in b1, we are just adding one more height to it, right? The height will be bk minus 1 plus 1, right? The maximum height in bk minus 1 plus 1, because we are also including a root in it, right? So it will be maximum height plus 1, right? Similarly, if we see for b2 what happens, similarly if we see for b3 what is happening is whatever is the height of b2, we are just like this, we are just putting it here, and then we are just adding one more node here or one more edge here, right? So the height will be whatever is the height in b2 plus 1, right? So if we are assuming that this particular property is true for k minus 1, then it means that the height of bk minus 1 is k minus 1, right? If the height of bk is k, then the height of bk minus 1 should be k minus 1 if we are assuming it to be true for k minus 1, right? So what will be the height of bk? Whatever is the height in bk minus 1 plus 1. So what is the height in bk minus 1? K minus 1. So height of bk, height in bk is equal to height of height, maximum height in bk minus 1 plus 1. So it is k minus 1 plus 1. So what is it? K. Right? So the height of a binomial tree bk is k, right? Next property is there are exactly k c I nodes at depth I for I is equal to 0 to k. Okay, so this you need to understand a little carefully. Okay. So it is saying that exactly k c I nodes at depth I for I is equal to 0, 1, so on k. So we are assuming this to be true for k minus 1, which means there are exactly k minus 1 ci nodes for depth I at depth I for I is equal to 0 to k minus 1, right? And that is in bk minus 1. If we look at any depth, then the number of nodes at depth at that particular depth is k minus 1 ci, right? So a node in bk minus 1 appears in bk once at depth I and once. Okay, so a node at depth I in bk minus 1 appears in bk once at depth I and once at depth I plus 1. What I mean to say is, in case there is a node at depth I, what is the depth of this node? 1, right? What is the depth of a node? Depth of a node is the number of edges in the path from root to that node. So the number of edges in the path from root to this node is 1. So depth of this node is 1, right? So depth of this node is 1. So is this node, if it appears in bk minus 1, that is b2, at depth I, this node appears once at depth I in b3 and once at depth I plus 1. That is, this node will appear once at depth 1 and once at depth 2 in b3. That is, let us see, this node is, where is this node appearing? Here. These two are the same node, right? And this node is also appearing here, right? So this is appearing at depth 1 and depth 2, right? What I'm trying to say is, a node at depth I in bk minus 1 appears in bk once at depth I and once at depth I plus 1, right? So a node at depth 1 in b2 appears in b3 once at depth 1 and once at depth 2. So where is it appearing twice? It is appearing once at depth 1 and once at depth 2. You can take this for any node, right? Let us talk about this node in b3. Where is it appearing in b4? It is appearing at depth 1 in b3. So where is it appearing in b4? It is appearing here, and also this one is appearing here, right? So this is appearing twice, right? This node is appearing twice. Two b3s are joined to form b4, right? So it is appearing twice here, once here and once here, right? So what is the depth here? Depth here is 1 and depth here is 2. So a node which was appearing at depth 1 in b3 is appearing twice in b4, once at depth 1 and once at depth 2, right? So these two are the same node. Do you have any confusion in that? Because these two b3s are joined now. So one b3 is joined like this and one b3 is attached. One b3 is present here, right? And one b3 is present here. This is a b3, sorry, this is a b3, this one is a b3 and this one is a b3, right? Wait a second. Yeah. So this one is b3 and this one is b3. So there are two b3s, right? So this node is here and here, two terminal nodes, right? So it is appearing once at depth 2 and once at depth 1. So any node that appears in depth I, at depth I in bk minus 1 appears twice in bk, once at depth once at depth I and once at depth I plus 1, right? So the number of nodes at depth I in bk is the number of nodes at depth I in bk minus 1 plus the number of nodes at depth I minus 1 in bk minus 1. How is this possible? It is saying that the number of nodes at depth I in bk, this is equal to the number of nodes at depth I in bk minus 1 plus number of nodes at depth I minus 1 in bk minus 1. So number of nodes here is the number of nodes at depth I in bk minus 1. How is this possible? These three nodes are at depth 1, right? These three are at depth 1 in bk minus 1. What is bk minus 1? b3, right? So these three are appearing here as it is. Whatever is present at depth I in bk minus 1, it is present in bk also as it is, plus at depth I, the number of nodes at depth I minus 1, this particular node is appearing here. Got it? What I mean to say is the number of nodes at depth the number of nodes at depth I in bk is the number of nodes at depth I minus 1 in bk minus 1. So what is I here? Let us talk about this. Number of nodes at depth 1. I is 1, okay, and bk is k is 4, okay, and k minus 1 is 3 now. Okay, so the number of nodes that are present at depth 1 in B4 is equal to the number of nodes that are present at depth 1 in B3, that is these 3, plus the number of nodes that are present at depth 0 in B3, right? So what is the node present at depth 0? This one. So you can check it for any particular depth. Let us say I want to find out the number of nodes at this particular depth, right? So it is equal to the number of nodes at depth I in BK minus 1. What are the number of nodes at depth I? So what is this depth? 2, 1, 2. So these 3 nodes will appear like this. These 3 nodes will be present as it is here. Okay, so which are these 3 nodes? And then plus the number of, so it is getting a lot of clumsy, it is getting very clumsy actually. I have created this tree and brand new tree again. Okay, so in case we are talking about depth 2, the number of nodes at depth 2 in B4, this will be equal to the number of nodes at depth 2 in B3, that is number of nodes at depth 2 in B3. Which nodes are at depth 2 in B3? These 3 nodes. So these 3 nodes are appearing just like this here. Okay, plus the number of nodes at depth 2 and number of nodes at depth 1 in B3, right? Which are the nodes that are present in depth 1 in B3? These 3. So these 3 are also present here. Okay, so what was the rule? The rule is like this. The number of nodes, let us say D denote the number of nodes at depth K, at depth I in BK. This is equal to the number of nodes at depth I in BK minus 1 plus the number of nodes at depth I minus 1 in BK minus 1. Okay, so if we are assuming this property to be holding true for BK minus 1, what it will mean, at depth K it has KCI nodes, right? So at depth K minus 1 it will be having K minus 1 CI nodes, plus at depth K minus 1 plus at depth I minus 1 it will having at depth I minus 1 it will be having K minus 1 CI minus 1 nodes. Got it? What I mean to say is, in case if this is true for BK minus 1, it means that the number of nodes at depth I in K minus 1 will be K minus 1 CI, and the number of nodes at depth I minus 1 in K minus 1 will be K minus 1 CI minus 1. In case you do it, you will get KCI. Okay, so we assume this to be true for K minus 1 and we got this to be true for K, right? I don't know if you want that proof or not, but I hope you understood, right? That is, a node at a particular, the number of nodes at a particular depth in particular binomial tree BK is equal to the number of nodes at a particular depth in BK minus 1 and that depth minus 1. That is, at that number of nodes is in this particular depth is equal to number of nodes at that depth in K minus 1 and number of nodes in the previous depth, right? Depth minus 1. Okay, so that is the case for this particular, that was the property and that was the proof for this. And also the root has degree K. Okay, so the root has degree K. Also I didn't show you the diagram. Let me show you the diagram how BK minus 1 is connected to form BK. Okay, so BK minus 1 to BK minus 1 are connected like this. One says this is BK minus 1 tree and this is BK minus 1 tree. Okay, so this is BK. This BK is formed by 2 BK minus 1, right? So what is it saying? The root has degree K which is greater than that of any other node. So why the root has degree? So the root has degree K which is greater. What is the degree of a node? Degree of a node is the number of children it can have. So it is saying that root has the maximum degree in a particular binomial tree. And what is the degree here? K. So let us assume that this particular property is true for K minus 1. Then it means that the maximum degree in the tree by okay, so a node at where were we? The root has degree K which is greater than, okay, so the root has degree K. Okay, so we are assuming that this particular property is true for K minus 1. Just like for all the other properties, we are assuming this to be true for K minus 1, right? So it means that this tree, the subtree BK minus 1 has the root of the subtree bk minus 1 has degree k minus 1, right, which is greater than all the nodes in that particular tree, right. What I am trying to say is that this subtree bk minus 1 has its roots degree as k minus 1, right, according to this particular property. Alright, so what we are saying that in this particular subtree, what is the maximum degree? What is the maximum degree in this particular subtree? K minus 1, which is that of its root, right? Which is this particular node. Now, in this particular subtree also, its root, that is this particular node, will have the maximum degree, which is k minus 1, right. So the only node that can have a degree greater than this is this particular node, this particular root. Why? Because these two are linked to form bk minus 1 and only this node. Okay, so can any other node will be having more degree than this particular node? No, because in bk minus 1 we have already stated that, or it is already established, that is this particular property we have assumed to be true for k minus 1, right, which means that in k minus 1 this property already holds, that the root has the maximum degree, and here also the root has maximum degree. So the only node with the greater degree than in bk minus 1 is the root node, which will have one more degree than in bk minus 1. So if the degree in bk minus 1 is k minus 1, then in bk the maximum degree will be k minus 1 plus 1 is equal to k. So the degree of the root will be k, right. That is about the root has degree k, which is greater than any other node. If the children of the root are numbered from left to right by k minus 1, k minus 2, so on 0, child I is the root of subtree bi. Okay, so for this, let us again construct the tree. B0 we have, B0 we know, B1 we know, right? Okay, B0, B1, let us just draw B2, okay? This is B2. Let us draw B3 using this as well. B3 includes this and then this, okay? And then another one includes this. Okay, so it is saying, so let us talk about bk minus 1 and bk. Let us say k is equal to 4 and k minus 1 is 3, okay? So in case if you see, this is b2, isn't it? It's b2, right? If I number the children from 2, 1, 0, let us say I say this 2, this is 1, this is 0, okay? So I have numbered this, right? So what is this? This is b2, this is b1, isn't it? This is b1 and this is b0. Right, so this is the now this child is the root of subtree b2, right? This child, the child 2, if I take k is equal to 3, right? If I am talking about b3, then what happens is if I number the children from left to right by 2, 1, 0, right? 2, 1, 0. So what happens is that this particular the child I, that is child 2, let us talk about child 2, it is the root of subtree b2, isn't it? This is the root of subtree b1, this is the root of subtree 0, right? b1, b0, this is b1 and this is b0, this is b0, this is b2, right? Now if I talk about b4, what happens is this is b3, isn't it? This is b2, this is b1, this is b0, right? So in case we number the children from left to right by 3, 2, 1, 0, that is from k minus 1. If we are taking k is equal to 4, then if I number the children from left to right by 3, 2, 1, 0, then what happens? Child I is the root of subtree bi. Child I, that is 3, is the root of subtree bi. This is the root of subtree b3. This is the root of subtree b2. This is the root of subtree b1. This is the root of subtree b0. So this is very trivial property, right? So this you can directly make out from the image, right? I hope this is clear, all the properties of the binomial trees and everything. Okay, so we will discuss binomial heaps. Did I say binary tree now? Okay, so we are done with discussing binomial trees. In the next video we are going to be discussing about binomial heaps. Okay, so I hope you got this. In case you have any query, you can let me know in the comment section down below. Also tell me what videos or what topics you want to watch next. Thank you for watching. I'll see you in my next one. Till then, subscribe to my channel if you haven't, and if you like this video, then please don't forget to press the like button. I'll see you in my next one. Bye.